Okay. Just I guess before we get started, just want to check in and see how you guys are doing, how you guys are feeling. How's Git and GitHub? Is that working for you guys? Are you guys using that to kind of get the class notes at all? Maybe, kind of. And so I asked the TA Thomas to go over this tool called NBDime, Notebook Diff and Merge, to handle merge conflicts with Jupyter notebooks. Okay, so normally merge conflicts with a plain text file, no big deal. GitHub will enter all of these kind of greater than, less than signs to kind of indicate the start and end of the merge conflict. But if GitHub does that, or if Git does that to a Jupyter notebook, it causes the Jupyter notebook to crash. Okay, because it like messes up the headers and whatever, and the notebook can't even be rendered. And so in order to handle that, you need a tool called Notebook Diff and Merge, and that allows you to kind of resolve conflicts that might arise when you merge changes from with the Jupyter notebook. Okay. Anyway, just kind of watch the videos and the links regarding GitHub and all of that, and the hope is that you'll become comfortable using Git, become comfortable with fetching changes and merging them, or Git pull does that, and also pushing your changes and then adding and committing them and whatnot. Anyway, today we will continue on just in kind of some of these Python basics, and we left off talking about lists last class, and we had list copy and list append and insert and extend. So insert allows you to add kind of one item to it, and extend allows you to attach an iterable, extend your list by an iterable, and we also saw that you can use the kind of the plus operator to extend a list. You can also extend a list by kind of using list slicing in conjunction with assignment, and those are all ways to kind of extend a list. All right, over here I've got an example of this concept of copy, shallow copy, and deep copy. Okay, so here I have I've created a list A. Let's see if I can make this even bigger for you guys to see. We'll go full screen here. Okay. So I've got A, which is character A12, B is B34, and then C is a list that combines A and B. So C is a list of lists, and so here I'm going to create D, which is going to be a copy of C. Using this slice notation, I create a copy of C. Okay, that's a shallow copy. And then meanwhile, I use E using the tool copy.deepCopy, and I'm going to create a deep copy of C. Okay. Now, and then what I'm going to do is I'm going to append X to C, and we will see that C changes, but D and E remain unchanged. Okay. And that's because they are copies, right? So the whole idea of a copy is when you change one thing. So lists are mutable, and so I can change it by appending X to the list, and that modifies C. But D remains the original version of C, and so does E. Okay. This is where we see the differences between a deep copy. Okay, deep copy versus a shallow copy. So when I created list C, it references. It's basically a list of the object A and the object B, okay? And so if I append Z to to the list A, okay, and I ask to print out C, it's going to modify A to be A, 1, 2, and now Z, okay? And so C will reflect that by having A, 1, 2, Z, and then B, 3, 4, and X. D is a shallow copy of C, and so it references this same object A that now includes Z. Whereas the deep copy of E, when I created the copy of E, doesn't reference objects A and B, but it actually created copies of those things as well. So it creates a deep copy. And so so here, after I append Z to the list A, C and D both refer to list A, because C was created by A and D is a copy of that where it references A. And so so those lists are extended by including Z. Okay, C was modified earlier by appending X to it, and D doesn't. Whereas E is a deep copy, and so it doesn't reference the same thing, and it remains unchanged. Right. So that's the difference between a shallow copy and a deep copy. Okay, and if you understand these differences, then you understand what shallow and deep copy does. It might take just a little bit of kind of just referencing these things. Okay, lists also come with other methods. Okay, and so when you see something like this, you've got list.remove. You just basically use the name of the list and you do .remove, and these are things that you can do to the list. So here I've got list fam, which has all of these names, and you can just say remove object Emma in here. Okay, so if I do that, it's going to take the list, it's going to remove Emma, and it's going to print out what remains. Okay, so here I've got Liz 173, there's no more Emma, and then 1.68, so on and so forth. If you've got a list with duplicate items, so here I've got 0A, 2A, and 4, and I say remove A, it's only going to remove the first thing. So it reads left to right, and it only removes the first object that it encounters. Okay, and then if you ask it to remove something that doesn't exist, so here I have S and I say remove B, okay, which currently S is 0, 2A, and 4, it throws back an error. Okay, it gives you something called a value error. It says, you know, that the value you provided it is not valid. Okay, so that's object remove, and that's how you just kind of get rid of things from a list. Now we'll take a look at list.pop. Does something similar in that it kind of removes an object from a list, but it also it allows you to kind of capture the thing that you popped. Okay, so it's kind of the idea of you've got this, I don't know, like a chain of Lego bricks or something, and you're just kind of breaking off or popping off the item at the end. Okay, so here I've got this, and if I say here's the list fam and I do fam.pop, fam will be modified and it will pop the last value 1.89. Okay, you can actually capture the thing that we've popped. Okay, so J will take on the value 1.89, and so here I'm going to ask print out J, and it's going to print out 1.89. I'm going to say print out fam, and it's going to be everything but 1.89. Okay, and so so we have that. If you want, you can specify an index. Okay, and it will pop the item in the list at that specified index. So here I've got the original list, and if I say pop 0, it's going to pop Liz. Okay, and it will capture the value that got popped or removed from the list into wherever you're storing it. It returns that, and so we can print J. J will take on the character string Liz, and fam will be everything but Liz. Okay, so we have that. And then you have another method, fam.clear. It just kind of deletes out all the contents of the list. Okay. And so when I print fam, we see that it's empty. Okay, so it's important to note that kind of all of these operators, all of these methods, just modify the list directly, and it doesn't actually print anything onto the screen. In all of these cells, I've been asking print, what the resulting list looks like, so we could actually see it. But when you're writing your code, you're not going to get any kind of feedback unless you specifically ask for it. You just have to be aware that this is actually modifying the list. Okay. Over here, though, these do not modify the list. They are just methods, but they return values. Okay. So, for example, list.index will tell you the index of where this thing is located. Okay. So here's the list fam, and if I ask what is the value, what is the index of Emma, what will it return? So Emma is the third item in the list, which is going to have index 2, right? Because it starts, the index starts at 0. Python lists are 0 indexed, so it's going to return 2. The list also has a method called count, and you can count how many times a particular value appears. All right, so here if I say count A, it's going to go through the list and it's going to say that appears 3 times. All right, so it gives that back. And here I've got a list of lists. Okay, there's 4 things in here. So if I say where's Emma, Emma is not an object in the list. Okay, because it's a list of 4, and none of those 4 elements is just the string Emma. Okay, I can ask if one of the objects in the list is Emma 1.68, and it will return that there is one of those things. Okay, and so that appears right here. So these are things that we can do. Okay, here are some things that we have to also talk about. You can sort and you can reverse a list, and these are methods that actually change the list itself. Okay, so if we just ask here's list fam, it looks like this, right? We've got Liz 1.73, Emma 1.68, things like that. Okay, I could call fam.reversed. Okay, it's going to just reverse the list itself. Okay, when you run that, it runs and there's no output. It doesn't actually return anything. It doesn't print anything onto the screen. You just have to know that, okay, I ran this, and so the list was actually modified. So if we call what does fam look like, it's going to be the exact same list, but it's just in reverse order. Okay. You can say sort this, but this is going to throw back an error because it doesn't know how to sort strings and lists together, right? To sort, it says it doesn't support instances of string and float. Okay, so we get an error there. So here's a list. Okay, so here is some digits. 4, 2, 7, 9, 2, and I even throw a float in there, 5.1 and 3. Okay, lists allow for different types of data types in there, so it's no problem that I'm mixing the integers along with the floats. Okay, and here I can call some digits.sort, and again this will sort the list in place. Okay, and it doesn't look like anything has happened, but it has. Okay, by running somedigits.sort, the list is now sorted. So if I say, well, show me what this list looks like, and I call print, it appears here. Okay, and the digits have been sorted from least to greatest. Okay. And if I ask, what is the type of the index 4, it's going to say it's float. If I ask for the type of anything else, it'll return an integer. Okay, so you can so it preserves the fact that it's integers and floats and things like that. You can also take the thing and you can run sort with reverse equals true, and it will sort them from greatest to least. All right. Again, the sort command sorts it in place. Okay, the sort method. So you take the method and you call sort on it, it'll sort it in place. Over here though, okay, here I have some digits. We establish this list, and there's a function called sorted, okay? This returns a copy, okay, a sorted copy of the list. So it does not, sorted is kind of like what R's function sort does. It leaves the original list unaffected, but it will return a sorted copy of it, okay? So here, if this is the original list, sorted returns a sorted copy, whereas the original list is unchanged, okay? So don't get these things mixed up, okay? You have the list.sort method, which will sort the list in place. And then you have the function sorted, which will return a sorted copy of the list, right? For our users, when we call sort, this is kind of what we're accustomed to. This is similar to how R's sort function works. You have a vector, you call sort on it, it's going to leave the original vector in place and unchanged, and it returns a sorted copy. Not so with Python. We call this sorted, that's what we have. Whereas if you have the list and you use the list name .sort, it sorts it in place. All right, is that okay? All of this mutable stuff happening in place, nothing happening on the screen, right? All right, we have other object types. This one is called a tuple. A tuple is a lot like a list, okay? Except the tuple is immutable, meaning that all of these things where you were able to modify the list in place, like do list.sort, list.append, list.extend, these are all things that modified the list in place. None of those things exist with a tuple, okay? A tuple allows you to kind of mix up data types, much like the list, except once you've created a tuple, that's it. There's no modifying the tuple, okay? If you want to change it, you have to just redefine the tuple. You have to create a new tuple with different stuff. You can't just say, I want to change this thing in the tuple, okay? So because of that, tuples only have two methods, tuple.index and tuple.count. These are the methods that lists have that didn't modify anything about the list, okay? Pretty much all of the other methods that the list does, maybe tuple might have a copy, but pretty much all of the other things that the list does that allows it to kind of change in place, those things do not exist with the tuple, okay? So here I'm creating a tuple. You can index them and say what's the what is at index 1, and this will say apple because we've got 0 indexing, so we've got apple. You can do slicing, okay? So what will slice 2:5 return? 2 cat and dog, right? Okay. You can ask what is what's the index of dog, and that will return 1, 2, 3, 4. Okay, and then count how many times does 5 appear, and it appears once. Okay, so over here I'm creating two things. With T, I can T will be the tuple, and L is the same thing but a list. Okay, and the only difference when you create them is with the tuple you have parentheses, and with a list you have square brackets. Okay, and so if you use parentheses like this, Python sees this and calls this a tuple, okay? And we'll say this is immutable, it cannot be changed, or cannot be modified. With a list, you use the square brackets, Python sees that and says, okay, we've got a list, okay? So T is the tuple, L is the list. So here with the list, I could say change the value at index 0 and assign the value 100 to that, okay? So we can do that. And it works, okay? L now has 100, apple, 2, cat, dog, 5, 6, okay? Over here, if I try to assign the value 100 to the tuple, the index 0, okay, it's going to throw back an error. Okay, it says tuple object does not support item assignment. Okay, so we can't do that. We can't do anything that's going to modify the tuple. If you want to redefine the tuple, you can redefine the tuple, but you can't modify it. If you try to append or insert or anything like that, pop, all of these things will fail. Okay, it's a tuple has no attribute append. Okay, whereas with the list, we can do that. We can append the value x to the list, no problem. Okay. If you don't use parentheses or something like that, okay, and if you just write some commas and you say, I'm going to assign this to A, okay, by default, R creates a tuple, okay. So here I'm going to say A is equal to 1, 2, 3, 4, and I say print A is going to be a tuple, okay. So by default, we see the parentheses, and that tells us that we've got a tuple going on, and it tells us we've got class tuple here. Is that all right? Okay, and so you might wonder, well, like, why would I want a tuple instead of a list or things like that? Tuples are generally used, like, if you create a tuple, it means this is something that should not change, okay? And if you create a list, there's kind of an implicit understanding that it's okay to append things or modify the values in the list. So if you ask for like later on in NumPy, we'll create matrices and stuff or arrays, and you ask, what are the dimensions of an array? Okay, the dimensions of the array will be a tuple. It will be something like 10 by 3, okay? And it's going to be parentheses 10, 3 to indicate that these are the dimensions of the matrix. I can't just append a number to this, and well, it's not intended where you just change the dimensions of the matrix and it redefines the thing or something like that. Okay, so we've got these kind of tuples going on here. Okay, you have functions that support lists and tuples as inputs, and we saw the function sorted already, but we also have the length, sum, min, and max, and these are they do exactly what you expect them to do. Okay, so here I've got digits, which is going to be a tuple of numbers, and words, which is a list. So I can say, what is the length of the digits, and 7 and sum will give me the sum of those things. Okay, and if this were a list, it would also work. Okay, and obviously you can't sum the words where it's strings. It's going to give us an error and say, I don't know how to sum letters together. No problem there. Sorted, again, we'll sort it, right? And so because sorted returns a copy and leaves the original thing unmodified, you can call sorted on a tuple and you can call sorted on a list. Okay, so sorted does not try to modify the original tuple. Okay, so it returns a sorted copy. However, when you call sorted, it becomes a list. Okay, for whatever reason. So sorted will sort the tuple, but it leaves the original thing unchanged. Okay, and again, we can show that the sum digits, that thing is unchanged. Same thing with the words. It's going to do sort them alphabetically if you call sorted, and you can call min on a list or tuple, and it will return the smallest value. And min and max, if you did it on strings, will return kind of the first or the last word if you alphabetized them accordingly. Okay, and again, if you have a list where you have mix a mix of types, a mix of integers and strings, then a lot of these functions break, okay? So pretty much if you have a list where you have numbers and strings, pretty much the only thing that will work will be length, okay? Because you can't sum things, and when you call sorted min or max, it doesn't know how to sort these things because it's a mix of strings and numbers. All right, is this okay? All of this stuff? Okay, we have strings. Strings are immutable, okay? So if you call a method on a string, it does not modify the original string itself, but it returns kind of a new string object. It's going to return kind of a copy of the string that has been modified, okay? So for example, I have this string that says name, stats 131, Python and other technologies for data science, and I can say uppercase, okay? Name.upper, so name is a string, and you just do string.upper, it's going to turn this whole thing into uppercase. Name.capitalize will capitalize the first character in the string, and everything else will be lowercase. Name.title will capitalize the first character of each word, and name.lower will turn everything into lowercase. But again, these are the string itself is immutable, meaning that name, this string that says stats 131 Python and other technologies, this is not going to be affected. So when I say print out the name itself, that thing is not going to be modified, okay? So you can kind of see this is upper, and this is capitalized. It capitalizes the first character, and that's it. Title case, the first character of each word. Lowercase is everything, and then the original name is unchanged, okay? A lot of the methods and lists actually work on strings, okay? So you can say, well, how many times does the letter E appear? And it appears 5 times, okay? So there's 1 in other, and 2 in technologies, and 2 in science. So we have a total of 5 letters, okay? We can say, where is the first instance of a capital A, all right? And so remember here we are only working on the unmodified name, okay, which is this one. So what will name.indexA return? It will return 2, okay? So we're here, this is the one that we're working on, and it's going to say it's in the index 2, right? Okay. Does the string end with the letter K? That's going to return a false. Does it end with the letter E? That's going to return a true. And then there's other things. Does it start with the letter S? And that's case sensitive. Okay. If you want to write a string that spans multiple lines, you can use 3 quotes. Okay. So normally you just say a string is open quote and close quote, but if you want a string to span multiple lines, you can use 3 quotes, and it will do that. And here it is. Okay. Whereas you can run strip. Strip will remove all white space. Okay. So returns kind of leading and trailing white space. Whereas, but again, these are immutable, so the original string remains unchanged. Okay. Name.split will create a list of things after it splits out the string separated by spaces. Okay, so it kind of it searches for spaces to split the things, and it returns a list with kind of the different things in there. But if I just ask what is name 2, the original string is unmodified. Okay. I guess if I did print, okay, the original string is indeed unmodified. All right. So here is. So you might see an input where you get these numbers 2, 3, 4, 7, 8 or something, okay? And you can call string split, and by default it defaults to splitting on the space. So this is going not going to split these up, and you'll just have one thing in the list. Whereas if you say split on a comma, it's going to split them on the commas and return a list with all of the things in there, okay? So here we get a list with one element where it's a string of 2, 2, 3, 4, 7, 8, okay? And over here, now we get a list of characters where they were split on the comma. We have 2, and then 3, 4, 7, and 8, okay? And then if you wanted, this is called a list comprehension, which you haven't learned yet, but okay. So the list comprehension, what this will do, because it's really handy to have list comprehensions. It's going to take the result of number string.split, which is this list, okay? And it gives you back this character list, a list of characters, the character 2, the character 3, the character 4, and so on. And basically, we're going to iterate this. We're going to say iterate over each element, and we're going to call each element x. And what we want to do is we want to store x converted into an integer here. Is that okay? And so this will turn this list of characters into a list of integers, because we're saying iterate. So this is equivalent to writing for x in this. So I'll just write, whoops. So we're going to do okay. So this is pretty much the equivalent of this. Oops. L.append integer of x. Okay, so we start off with a blank list, and then we're going to say for x in number string.split, which is going to be this character string, or character list of characters, we're going to append the integer x, convert x into an integer and append it to list L. And they're going to return the same results there, okay? Is a generally more readable version of the following code, in my opinion, okay? Once you learn how to read a list comprehension, I think it's easier. I mean, you can always make things harder to read, but this is what it's doing. Maybe I shouldn't say more readable, but just more concise. And I guess concision, being concise, once you understand how it's being made concise, is often preferable. Okay, we have a few things that return true and false, okay? And so if we ask what is name, okay? Name says stats 131, Python and other technologies for data science, okay? So if we say, is it alpha? Alpha just means, is it made only of letters in the alphabet, okay? And all of these things, you can always just go search Google and you can say Python is alpha and to see what it does. And then also, on the other hand, the reverse, you can say Python, how do I check my string for alphabetical characters or alphabet characters? And surely the number 1 or number 2 hit will be your answer, okay? Which function does this, okay? So if I say ABBA-AZ, that will be alpha, okay? If I throw in a number 4 in there, this is no longer just alphabet letters, so it says false, okay? And then, you know, there's stuff like that, okay? Here, again, if I use triple quotes, it can span multiple lines. And if we want to do upper, we can take this long string and just do upper, and it'll look like we're shouting, okay? And if we want to turn it into a list, we can run on split, and it will split on all of the spaces, okay? Including new line characters; those count as splits. And so this is what will look like, right? So when you take that thing and you turn it into upper, it looks like this. And if you do split, you get a list of all of the words, okay? And it's interesting. You'll see that most of the words are encased in single quotes, with the exception of words like I've. And you'll see I've opens with a double quote, and then there's the apostrophe, and then the closing single quote or closing double quote there. All right, so that's what happens when you do take the string and you apply split. Okay, so these are all kind of just methods that Python supports for strings. Okay, you can do split lines, and it's much like split, except it'll only split on the lines. Okay, so whenever it encounters a new line character, it will put that into the list. Okay, so it's much like split, where split splits it on spaces. Split lines will split it on new line characters. Okay, and you can run all of these other things. Where is how many times does the letter E appear? Find an index will return back basically the index of the kind of the first time it encounters this thing. If it the difference between find and index is that if find can't find the thing, it returns a -1, whereas if index can't find the thing, it returns an error. Okay, so that's going to be the difference between find and index. And sometimes you want the error, and sometimes you don't want the error. Okay, yeah, question?
Is there a reason why when you use the index method, you don't have to use the print function? Whereas like other ones,
So all of these things where I've been printing, so some of the methods will do the action, but it will modify it in place and doesn't return anything, okay? Whereas some of the things will kind of return an output. And so if the function actually returns an output, then a lot of times I didn't bother calling print on it, okay? So here's a question. Does print return an output? No, it doesn't, okay? And that's why every time I call print on something, we don't see an out, okay? So the in and the out, this means when I did split lines, it returns an output and it gives us an out. Whereas over here, when I call print, so the assignment doesn't return an output and print doesn't return an output. So it puts stuff onto the screen, but there's no actual output. We can't reference this and things like that. Okay, so here I said print. I guess I could have, for something like here, I could have just then is alpha, and this will be an output. Okay, so the thing is with these Jupyter cells, if you so is alpha returns an output, and we know that. But the thing about Jupyter cells is that each cell is only allowed to have one output. So if I ran this, it will print out this thing, but it won't return the output here. It'll only return the last output. Okay, so that's why if I want to kind of just show multiple results, I'll have a print. So here's a print, and I can just leave the last one as an output, and we can see that it's going to be true. Is that all right? So Jupyter cells only allow one output per cell, but sometimes I like to kind of group these things together, and we want to see like multiple results. So I've been calling print on these things. But I guess, you know, on all of these, we can just see, well, what is L? And then it shows us the output. Okay, so strings can be subset. It's almost like you can treat them as if they were almost like a list. So you can say, you know, here's the alphabet, A, B, C, D, A through Z, and you can ask, what is at index 0? And that's going to tell us A. And you can slice it also, and you can say, what's between 4 and 9? Okay, so what will 4 and 9 return? 4 through 9. Okay, this will slice after the fourth letter. Okay, you can have to imagine invisible commas between the letters, and it's going to take you from E through I. Okay, and then -6. So it's counting 6 back from the end. So this will kind of pull U through Z. Okay, and then you can also treat them as an iterable, like. And run a for loop on it, okay? So you can say for x in kind of this thing from 0 through 5, so that will go from 0 to basically 1, 2, 3, 4, 5, E, okay? Print the letter plus an exclamation point, okay? And so it returns back A, B, C, D, E, all with an exclamation point. Okay, so this seems exciting, all right? But strings are immutable, so if I try to say, let's change the first letter in the string to B, that gives us an error, okay? It says you can't do item assignment, okay? If you want to do it, you have to just redefine S to be an entirely different string, but you cannot modify this string itself. What would I have to do if I wanted the first letter to be B and everything else to be B through Z? So basically I want B, B, C, D, E, F, G through Z. What would I have to do? I would have to do B plus take everything after the first letter, okay? And this will return what you want, maybe, okay? Okay, but you're not allowed to, you can't modify a string in place. Okay, they are immutable. Let's see, oh. How much time do I have? Okay, I'm going to run out of time. So you can, so here's just some nice features. Okay, so here I've got a list. List 1 is ABC and list 2 is DEF. Okay, if you take a list and you do multiplication with it, it will just take the elements of the list and double them. Okay, and extend, return one list where everything is kind of, the list has been repeated. Okay, you can take two lists and add them, and that's basically extending the list. You're taking list 1 and you're extending it with list 2. Okay, so this is pretty much does that with tuples. Okay, same kind of thing. Okay, because we're just creating new tuples. But you're not allowed to combine a list and a tuple. That gives a problem. But if you convert the tuple into a list, then it works just fine. It doesn't complain. Okay. And similar, you can do same things with strings. So I've got the string A, B, C, and D, E, F. You can take a string and multiply it by 2, and it just kind of extends that. You can take a string and you can add them together, and they just kind of paste them together. So this is kind of like a paste 0, but you're just adding strings together. You're just attaching them. Okay, I think we can get through this in the last minute. Okay, this is just trues and falses, right? Booleans are true and false values. Okay, and if you want to convert them into other things, you can. So I think we're all accustomed to this. So true is true, and if you turn it into an integer, it's 1. Float will become 1.0. If you turn it into a string, it's true. False becomes 0. Okay. Boolean will turn things into trues and falses, okay? And so Boolean called on none will return false, and Booleans called on 0 will return false, but pretty much everything else will be true, okay? Anything other than 0 will become true. So this is kind of just like when you call logical, as.logical in R, except we call them Booleans in Python. So you say 0, that's going to become false, okay? Anything else? So Boolean on -1 becomes true. X has to, nans are nans. Okay, this is not a number. Okay, but even if you call a Boolean on a nan, it becomes true. Okay, empty strings become false. Everything else becomes true. Okay, so you could say turn the character false. Because it's not an empty string, it's going to become true. This part throws a lot of people off. Okay, and then I think everything else kind of is expected. If you call Boolean on a list and stuff, it's going to return falses and trues, kind of as one might expect. Okay, we'll end there, and we'll see you guys on Friday.
I have a question. The last time you helped me